Welcome to this Sahara 4 exercise. In this exercise, we will calculate petrophysical data for the interval that we defined using the cross-section in the previous exercise. As a way to remember what we did, I will open our Sahara project here and I will go to the cross-section window and open our cross-section that we did in the previous exercise. So here we have a cross-section between these three wells. D7 is in the middle, and what we did was to define using the cross-section tool the interval for 23 for the layer 23 in D7, which is this interval. The issue is that when we save this, the petrophysical data is not automatically calculated. The only petrophysical data that is calculated is top and base, but for example gross thickness, net thickness, porosity, all of this petrophysical data is not calculated automatically, so we will need to do that in the petrophysical data window. First, we will check if these top and bases have been properly saved. We can see here, I will just hide this for a moment so we can see the value, but we need to keep it here. I will hide the SP just for a moment. So the proper top and base in the measure depth will be 5,877 and 5,877 and 68 or 67 and yeah, 77. So that's the value they want to check on the petrophysical data window, and we will also calculate using different methods the other variables, net thickness, total thickness, or gross thickness more properly said, and porosity. So now we will close this and go to edit petrophysical data, and here we have all the wells and all the variables selected. We will focus on the well that we want to and the layer that we want to check, so it will be layer 23 here, and the object D7 is here. And here we see that the values are correct. The top and base have been set properly. We are checking in measure depth in feet, so it's the same value that we had previously. It's the same. And what we want to calculate are all these ones: net thickness, gross thickness, and porosity. So if we check in this window, we have several options. We already reviewed this window previously, but we will focus now on the calculate options. Here we have a number of options here. We have for the neighboring wells, what this will do is using an algorithm called inverse of distance to calculate the values from the data of the neighboring wells. So it will check for all the neighboring wells and calculate based on the distance, inverse to the distance, the value, the appropriate value. So the wells that are closer will have a more similar value to the value that is calculated, and those that are far away will have less weight in the calculation for the value. From map values, it's quite simple. In the case that we have maps loaded, for example, we do have, let's just close this for a moment. In the case that we have maps loaded for the different variables, we have net thickness. Let's select the layer 23. We have net thickness here. D7 does have a value. I will hide the grid a moment. D7 is here, and we do have a value for net thickness. We do have a value for gross thickness and also for porosity. So we could use map here to calculate this. I will open again the petrophysical window here. So we could use that. The map values is just going to use the value of the map to calculate. The map obviously has been imported, so it's going to use that value. We have equations as well. Here we will have a different equation for each different variable, for each different column. If we click on any of the column, we can see which equations we have available. For example, for net pay, we don't have any equation because we cannot use any relationship between petrophysical data to calculate it. But for net thickness, we have this one. We have in this case, the net thickness is going to be calculated as the gross thickness of each combination of well and layer multiplied by the net to gross factor that we can define also as petrophysical data. For gross thickness, this is quite logical. It can be defined as the difference between top and base, which is going to use these two values to calculate. For porosity, we don't have any equation, and so on and so on. For example, for saturation, we don't have any, but for some other of the variables that we have in petrophysical data, we can calculate it from an equation. Then we have from layer to formation or well. In these options, you will be able to aggregate the information of the layer or the formation to create the value of the higher level. So if you're calculating in a formation, let's say that 23 here is not, we are not calculating for 23, but we are calculating in our structure. We can check in this red or magenta, which are formations, is going to aggregate using the aggregation function of each different variable that we review in the variable window. It will aggregate them together to create the value of the formation, or in the field level as well. You could aggregate the different values of the formation to also create the value of the at the field level, to create a value for the whole well. As an example, let's say that we want to calculate the porosity of the formation magenta. So we will select the all these layers together, all the one that has seen at first are belong to magenta. So we'll select all of them, and we will say, okay, I will to calculate this one. We will select magenta here and use the from layer to formation, and it's going to use the aggregation value of the variable porosity, which is a weighted average. We can check that quickly here. Remember that you can always check the aggregation function of the different variables by going here and looking for it in the correct group. So porosity in petrophysical data is a weighted arithmetic mean using the net thickness. It's going to use this aggregation function here to define the how to calculate the one at the formation level. I will open this one again, and you could also, if you want, for example, after that, if you want to create a porosity value for that well, not associated to any layer, just at the well level, you can do it again, selecting the well level, and it's going to aggregate between the formations, doing the same thing but at a higher level. And here apply value is the simplest. It's just applying the same value for all of them together. For example, let's say that this is the value that I want to use. Let's say that I want to have, for example, 20 porosity here, 20%. I just use 20 and I calculate. Sorry, selected cells. And here we have just 20. It's the most simple case. So that will be it for this example. So all of those are the functions that we have available here to calculate the petrophysical data for a combination of well and layer. In this case, as I said previously, we want to calculate these three. So what we'll do here is we will use an equation for gross thickness, because we already have the values defined. Because we already have the values defined for top and base. So in this case, we will use this one, this equation, just the difference between top and base is going to be the gross thickness. So in this case, we will select the cell that we want to calculate and go here, select the cells. And now we have a gross thickness of 10. And then for net thickness and porosity, we will use the map values that we saw earlier. So here we will go from map. Yeah, I want to save now because this is correct, and I will calculate here. So I will select this one, and we have a porosity of 17, which is a pretty logical value, seems correct. And here we have I have to save first. Remember to always save it before applying equations, because you won't be able to apply another equation if you haven't finished with the previous one. And here we have the net thickness is 11 almost. So probably we need to correct the gross thickness that we define here from this different top and base. We will do it quickly. Just do a small correction here. Probably my cross section was just too pessimistic. Let's see if I can modify it a little bit. Yeah, we can add a little bit on the top if you want. We will modify it and increase it a little bit like this, and like this. So now we save, And now we go back here to petrophysical data, and now these tops and base have been modified, and we can apply the equation here again. So let's go here, equation, and apply again. And now we have something that makes a little bit more sense between gross thickness and net thickness. And now we save. And now we have all the data correctly loaded into the well. We can check it, for example, using bubbles if we want to see if everything is correct. You can go here in bubbles, and here, for example, is porosity. Let's just check for the well that we selected. Here we can modify that objects, just the selected, and D7 has this value of 17%. If we want to check the values, we can do it here, and we see now that we have 17% as the, I will hide the references here, sorry. Here we have the 17 value that we loaded here. We can also check it for the other variables if you want, but that will be everything for this tutorial. We have used the petrophysical data window not only to show and to check the values that we created from another window, from the cross-section window, but we also use it to, based on these values, to calculate new values, new information, that now we can use for other things. Maybe, for example, we can use it to create allocation factors or things like that. So the petrophysical data window is quite a potent tool that we can use to fill our information regarding the, as I said, the petrophysical data of the wells and layers. So I think that will be everything for this tutorial. I hope it was useful, and thank you for watching. Have a great day.